Alright, in this video I'm going to be recording solutions for linear algebra homework 1.1, and this is going to be also more examples on dot product, cross product for vectors. Okay, so let's start. Okay, we're going to start with just some drill, right? We need to compute some dot products and cross products so we know what we're doing. Alright, so let's start with u dotted with v. 2, negative 3, 7, dotted with 1, 3, 1. We're going to just multiply corresponding entries and add them all together. Okay, so that's going to be 2 times 1 plus negative 3 times 3 plus 7 times 1. Okay, I'm going to say that's 2 and 7 is 9 minus 3 is 0. Okay, so look at that. Looks to me like u and v are orthogonal. Okay, so that's something nice. Looks like, oh, I see another one that's going to be orthogonal. I think u and w are also going to be orthogonal. I stole these three vectors from some pages of the textbook, and maybe that's what they were getting at. Anyway, u crossed with v is going to be, set up my little matrix, I, j, k. U is 2, negative 3, and 7. V is 1, 3, 1. Okay, so it's going to be I minus j plus k. Oops, didn't realize I was running out of room there. All right, and so what I'm going to do is I'm going to cover up I. I'm going to take the subdeterminant, really what that is. Negative 3 minus 21 minus j times 2 minus 7 plus k. This is 6 minus 3. 6 minus negative 3. All right, that's where the errors come in here, right? It's subtracting negatives. So this is going to be equal to, okay, basically negative 24i plus 9 no plus 5j plus 9k. So maybe I'll say, okay, negative 24 to write it as a vector, as a column matrix, really, which is how I'm going to write a vector almost always in this class. Negative 24, 5, and 9. Okay, that's us crossing u and v. All right, now let's cross w by u. Okay, w cross u. And so I'm going to set up the same way, I, j, k. I have to see what w was, 320 by u, which was 2, negative 3, 7. Okay, so see me when I lean down. I don't know if you need to see that, but I'm going to cover up I, and that'll be 14 minus negative 3, so that's 17 minus j times 21 minus 0 plus k times negative 9 minus 4 is negative 13. Okay, so equals that equals vector 17, negative 21, negative 13. That's all of them, right? Okay, number 1, under number 2, find the values of C1 and C2 so that AB is equal to CD. Okay, well, okay, if that's AB, and so that's negative 2, 3, 2, 2, negative 1, definitely not drawn to scale or with correct orientation, so suppose they're like this. I want AB. AB, well, what did I do to get from A to B? That's the question. So I went from negative 2 to 2, that's 4 in the x direction. I've increased by 4, and I've decreased by 4 in the y direction. Okay, so that's AB. And let's see, CD, okay, we don't know C, so that's C1, C2, and then D is 3, 2. All right. Okay, if we want this to be the same vector, then I need CD to equal 4 and negative 4. So basically I need to find something that if I add 4 to it, I'm going to get 3. Okay, so C1 is -1. And C2 is going to be positive 6. If I take 6 and I subtract 4, I'll get the 2. Okay, so, you know, the coordinates of point C is -1 and 6. All right, find B equals B1 and B2 so that V is AB. I think I'm going to just draw a very similar picture here. V equals 2, 5. And A is 1, -2. And so we need to find a B. So we've got here 1, -2. We've got V. And so that will be B right there. Okay, so it seems like I really just need to add add V to A, and I'll get B. So 1, 2, and I'm going to add 2 in the x direction. So 1 plus 2 is 3. And then in the y direction, I'm going to add 5, so that's -2 plus 5, also 3. Okay. Sheet paper. All right. Number 4. Let U be and V be given. A is the... Oh, yeah, I saw this one, copied it out of the textbook. I have not ever worked this problem before. It looked kind of interesting, so I'm going to just jump in and do it. So we've got U and V. Here's A. So U is AB, so I'll put B here, call that U. V is BC. And U plus V is equal to AC. Okay, that kind of makes sense. You know, I'm not sure if I told you all that about vector addition and stuff. I kind of took that for granted, but yeah, it works the way you expect. So, all right. So, A is the point 2, -1. Meaning that B is A, but, you know, added U to it. Same. Okay, so 2, 1 and 1, 3 is going to be 3, 2. And then C is equal to B, and then I'm going to add V onto it. So 3 and 2 is 5, and 2 minus 2 is 0. Okay, this seemed like, why did I need that condition? Makes me wonder if I copied the problem wrong. Anyway, let's think. All right, how am I going to check if U plus V is AC? Well, I'll just find U plus V. U plus V is 3, 1. Yeah, and okay, AC is, AC is V, right? Because I added 3 to get 2 to 5, and I added 1 to go from -1 to 0. Okay. I'm not sure if I copied the problem wrong, or if you set it up this way, that necessarily it's going to be the case that U plus V is equal to AC. It seems like that's what's going to happen. All right. Suppose V has the same direction as the vector 2, 1. The length of V is 4√5, and the coordinates of point A. Okay. It's very, very similar. So what we're going to have to do is, I think I'm going to draw the picture for you first. So we've got AB. Okay. V is equal to AB, so I'm going to put that in there. A is -4, -2. Length of V is equal to 4√5. Okay, and then V is in the direction of 2, 1. Okay, so there's a number of ways that you could do this. You could probably do this purely with trigonometry, right? You could turn this into a right triangle, find the angle that corresponds to the vector that has coordinates 2, 1. You're going to use arctangent, and go from there. I'm not going to do that. I'm going to try to do this, a very vector way. So basically what I'm going to do is I'm going to take v and I'm going to shrink it down to a unit vector. So usually the notation we're going to use is uv. The unit vector in the direction of v is going to be v divided by the length of v. Okay? And that's going to be, well, I don't have it written down here, but I think, yeah, v is, what is it, 2, 1. Divided by the length of 2, 1. Well, the length of 2, 1 is going to be the square root of 4 plus 1 is 5. Right? And so that's going to be 2 divided by square root of 5 and 1 divided by square root of 5. That's the unit vector in the direction of v. Now, if I want to have something in that direction that has length 4 root 5, I'm going to take the unit vector and I'm going to scale it up by 4 root 5. Okay, like that. Okay, and so I've got the unit vector. If I want to scale it up by 4 root 5, I'm going to multiply both of the components by 4 root 5. All right, so I'm going to say that v is equal to 2 times 4 root 5 divided by square root of 5. And 1 times 4 root 5 divided by square root of 5. Okay, we're going to have this happen, and we're going to have 8, 4. And if you want to, you can check on me and make sure that the length of this is in fact 4 root 5, which would be, yeah, if we added it together, it needs to be 80, because 16 times 5, if we square this, 64 and 16 is in fact 80. Okay, so I feel good about that. And it's pretty clearly in the direction of 2, 1 also, right? Because it's like the x component is twice the y component. Anyway, okay, so if I've got a and I'm adding v to it, and that's v, then b is going to be equal to negative 4 plus 8 is 4, and negative 2 plus 4 is 2. You got a better way of doing this one? Let me know about it in class, please. Find a unit vector that has the same direction as the given vector. Should have put this problem first, right? Definitely. Would have been good if I'd gotten you some practice on that before you actually needed to do it, but, you know, you live and learn. Okay, so a equals negative 1, 2. The unit vector in the direction of a, well, maybe I'll just write down the length of a. It's going to be the square root of negative 1 squared plus 2 squared, and that's going to be, again, the square root of 5. I'm going to say that the unit vector in the direction of a is equal to a divided by the length of a, which is going to be, okay, negative 1 over the square root of 5 and 2 divided by the square root of 5. Okay, and then the next one is going to be b is equal to I plus 3j minus 2k. Make sure 1, 3, negative 2. Cool. And I'm going to just right away write this as 1, 3, negative 2. All right. So length of b is equal to the square root of 1 plus 9 plus 4. That's going to be the square root of 14. The unit vector in the b is going to be b divided by the length of b. So I'm going to take the components of this, I'm going to divide it by the square root of 14. So I'll have 1 over the square root of 14, 3 divided by the square root of 14, and negative 2 divided by the square root of 14. And with these, if you want to check on me and make sure that these are in fact unit vectors, you could take the length of them by squaring each of the components, adding it all together, and you would see that it's going to add to 1. Okay, number 7, find a vector u that has the opposite direction from 101 with length root 32. Did I copy that problem twice? No. Okay. All right, so this is going to be, say that's 101. Okay. The unit vector in the direction of 101 is going to be, well, the length of this thing is the square root of 2, right? Square root of 1 plus 1. So 1 over square root of 2, 0, 1 over square root of 2 is the unit vector in that direction. If we want it to go the opposite direction, we're going to multiply everything by -1, right? Because always implicit, if we're just talking about vectors in general, so we're kind of starting from the origin, okay? And so I'm just going to reverse that by multiplying it by -1. Okay, so we want the opposite direction, and that's going to give me 1 over square root of 2, 0, and 1 over square root of 2. And then I need to have length root 32. So I'm just going to take this and I'm going to multiply it by root 32. Okay. If you want, you can say, okay, wait a second, I'm going to divide these. That's going to be the square root of 16. That's 4. I can do that twice, and that's... Wait, I didn't actually make it the opposite direction. Disappointing. At least I caught the error, though. All right. Number 8 is determine which vectors satisfy the given conditions. All right. Okay. So I'm going to just say I'm going to call it U1, U2, U3. Right, that's going to be, and I need I. That's 1, 0, 0. J is mentioned in this problem, so I'm just going to copy that as well. 0, 1, 0. That's going out of my shot. Okay, and so U dotted with I is going to be U1 plus 0 plus 0. But then they told me in the statement of the question that U dotted with I has got to equal 1. Okay, so that means U1 equals 1. Okay, I've got that coordinate set. U2 dotted, or U dotted with J is going to be 0 plus U2 plus 0. It's going to be U2. That's not a vector. That's just a number. It's the number that's inside of the vector, the second component. Then they told me that was 3. So I've got U1 and U2 set. Okay, so maybe I'll just kind of put my answer here. So it's 1 and 3, and I'm not sure what the third component is. All right, and then they tell me that the length of U equals 4. Which means that U1 squared plus U3 squared, if I square rooted it, I would get 4, but I'm just going to say that if I add them all together, I'm going to get 16. Okay, because I know that I'm going to take the square root of 16 and get 4. So save yourself a little effort. I already know what U1 and U2 are. They're 1 and 3. So I've got 1 plus 9 plus U3 squared equals 16. Okay, I'm going to subtract the 10 from over here, and I'll have U3 squared equals 6. Meaning that U3 could be the square root of 6, but it could also be the negative square root of 6, and that's why they said determine which vectors, because there could be 2, right? So I'll say square root of 6, or it could be 1, 3, negative square root of 6. Rough. Hold on. Oh, where's my eraser? There it is. Call it the negative square root of, oh goodness. I forgot felt pens don't go so well with this. I'm just going to take the first pen I can find. It's blue, that'll do. Negative square root 6. Okay, that was a lot of effort. Negative square root of 6. Okay, number 9. Find the measure of the angle between P and Q. Okay, so we're going to need to use the cosine property, and so I'm just going to copy that for you. Okay, so for number 9, if we have two vectors p and q, it's going to necessarily be the case that p dotted with q, which is a number, is equal to the length of p, also a number, times the length of q, also a number, cosine of theta, the angle between them, that's a number. Okay. So first things first, we're going to find p dotted with q. Let's see. P dotted with q, where is it? 1, 2, 1. Dotted with -3, 6, -4. Equals, okay, so -3 plus 12 is 9, minus 4 is 5. Okay. I'm going to need the length of p and the length of q, and then I'll be ready to solve for cosine theta, and then I can solve for the angle. All right, so I'm going to say length of p equals the square root of 1 and 4 is 5 and 1 is 6. Add the length of q, that's going to be a little more annoying, but it'll be all right. That'll be 9 and 16 is 25. 25 and 36 is going to be 61. All right, and I don't know if you're watching this, and I'll tell you that for the quizzes and tests, I like to use Pythagorean quadruples so that we don't have like these really nasty numbers. So just like be aware that if it works out really nicely on the quiz or test, that means you're probably on the right track. All right, so I've got length of p, length of q. So I'm just going to kind of take this thing and plug in all the numbers I know now. So p dotted with q is 5. Length of p is square root of 6. Length of q is square root of 61. And then there's cosine of the angle in between them. So that means that I'm going to divide both sides by square root of 6 and square root of 61 to get cosine of theta. And that's going to be 5 divided by square root of 6 and by the square root of 61. Now that means I'm going to need a calculator to find, what that angle represents. And, well, I haven't had to use a calculator yet this year, so I'm going to have to go dig one up. I can use a scientific calculator. In this case, I'm going to report it to you in degrees. I'm probably just going to round to the nearest degree. Like, it doesn't matter. If you give it to me in radians, that's cool too. Yeah, we really aren't going to care too much. All right, so I've set my calculator into degree mode, and I'm going to take inverse cosine of, no, I don't have the fraction bar set. So 5 divided by the square root of 6 times 61 on the inside of the radical. And that will give me 75 degrees or so. Okay. That's how we find the angle between two vectors. That's going to be something that we're going to do repeatedly in this course. For reasons I can't remember, but I know we're going to do it again. All right. Find the area of the triangle with given points as vertices. This is something that I probably didn't hit in class, but is in the video. It's a fact that, well, if you watched the video, you saw that the area, or basically, okay, if you've got two vectors, I'll just draw the picture for you real quick. A and B in space. And we take the cross product, right? It's going to give us something that's orthogonal to both A and B, maybe something like that. But if we've got this kind of implicit parallelogram here, the area of that parallelogram is equal to the length of the cross product of the two sides, okay? Which means that if I'm trying to find the area of this triangle that has these given points as vertices, I need two of the sides to get something I can cross, find the length of that cross product, and then divide it by 2 to find the area of the triangle. Okay, that's my plan. So I'm going to, let's see, 0, 0, 0. Oh, that's convenient. Okay, so if this is 0, 0, 0, then it'll be really easy to find my two vectors I want. Okay, so B is over here. That's 2, 3, 4. And then I'll just say C is over here. C is looking like 1, negative 1, 2. Okay, so I've got kind of my two vectors that I'm going to cross. Okay, call it U and W. Okay, so I'm going to cross them. And it doesn't really matter which order I cross them in, right? Because it's not commutative, it's anti-commutative. But then if we take the length of the one that's the negative of the other one, they're going to have the same length. So it really doesn't matter what order. If I do W cross U or U cross W, doesn't matter. All right, so I'm going to say U crossed with W is equal to 2, 3, 4, 1, negative 1, 2. Okay, can't quite see all of that. All right, so 6 minus negative 4, 4 minus 4, and negative 2 minus 3. All right. 10, 0, negative 5. All right. So now the length of U crossed with W is going to be the square root of 100 plus 0 plus 25. Okay, that's cool. And that means that the area of this parallelogram is going to be the square root of 125. Therefore, the area of this triangle is going to be half of that. So I got that. Okay. Let's see. Oh, I got one more. Find a vector n that is orthogonal to the plane containing the points A, B, and C. This is going to be very, very similar. Again, I should have put this one above the one I just did, but that's just how it goes sometimes. I'm going to sketch A, B, and C. I'm going to actually just do it on the sheet of paper. How about that? Okay, I'll call it Y and Z this time. Okay. Y is the vector to B. So I've got increase by 3, did not change, decrease by 3. Z is from A to C, so I increased 1 in X, decreased 3 in Y, increased 2 in Z. Oh, yeah, maybe Y and Z weren't the best choice, but, you know, is what it is. Come too far now. Okay, Y crossed with Z is going to give me a vector that's orthogonal to both Y and Z, right? So if this is the plane here, if I cross Y and Z, say I do Y crossed with Z, with the right-hand rule, it's going to go down into the page. If I do Z crossed with Y, it'll come up out of the page. Regardless, it will be orthogonal to this plane that lives in my page. Okay, so let's just say Y crossed with Z is equal to JK 3, 0, negative 3, and 1, negative 3, 2. Whoops. All right, so 0 minus negative 9, or no, 0 minus 9 minus 6 minus negative 3, and K is going to be negative 9 minus 0. Oh, that's interesting. Okay. This vector, and I'm going to call it n, which is Y cross Z, is going to be equal to negative 9, negative 9, negative 9. That's interesting. Okay, what about Z? Is it really orthogonal to Z? Negative 9 plus 27 minus 18, sure enough. Okay. All right, that's all the problems from homework 1.1.